So first off, let's release the spindle lock. I don't know where that's at, right? Open the tool, rotate it counterclockwise, 10 to 12 revolutions. Make sure it moves really smooth, no burrs or anything like that. Wipe your faces clean like you're doing your calipers. With a lint-free cloth, your gloves will probably do okay. Just check them out real good. You got those shop towels?
I will bring some momentarily.
Check your faces, make sure they look good. Nothing there.
I've got some additional ones, some 2s and 3s over here.
I think we've probably already done this once. Turn the spindle back to 0 position by rotating clockwise. Use the ratchet to get it to your final distance of 0. Bring it all the way in and make sure it lines up with 0. Calibrate it. Once y'all get it down there, make sure you're within 1/2 of 1 graduation of the line width. Or if the micrometer has a vernier scale on the sleeve, the 2 graduations on the vernier must also line up with the appropriate graduation within 1/2 of a graduation line. Everybody's good? Nobody should need this stuff. They all should be pretty good if they're, they're brand new, so. Anybody's not line up at 0? Half, take it in and out a couple times, use your ratchet. Check your faces again. Are you doing it down to 0 on the 1-inch side?
I wasn't able to get down to 0 either. I was checking to see if it was.
Take it all the way down to 0 again. Okay, everybody's good. So now you're going to take the 1-inch gauge block and verify on the 1-inch side. I don't think everybody's got one.
So you got some various ones. So some people have some 1-inch ones, some 3/4 ones, some 1/2-inch ones.
Yeah.
Just look at the gauge
Just
block.
whatever your gauge block goes to then.
Just make sure you're verifying what size gauge block it is before you put down on it. Make sure that you get the right dimension. Make sure that your 2 shiniest sides are the sides that you're up against your micrometer, so you don't have sideways.
Is everybody coming in pretty close?
That one
That
is
was
not
good.
precision ground on those two sides, but it's
Good.
too, you can't, so this one is 700. Make sure you're on the two shiniest. Have you checked it the other way yet?
What are the bottom
Okay.
graduations
So
on the?
it's these two sides.
On
are
this
your
one?
Gauging
Yeah,
side,
on which
750.
On the metric one? They're half millimeters.
That's where it should be.
And then you add like the ones here and then the ones up top together.
Do you want?
So like, say from 10, I would add this and then whichever one lines up next to it.
Right. I think everybody's about good there.
You guys still working on theirs?
Okay, we're gonna move on to the 1 to 2 mic. Same thing, release your spindle, turn it out some, clean your faces up, make sure there's no nicks, burrs, anything, everything moves freely.
I keep saying I'm gonna order some M1. I'm gonna do it now while it's on my mind.
Good idea. Once everything checks out, go ahead and check it with a 1-inch gauge block or whatever you've got over there. If it's over 1 inch, check it out. Make sure everything comes back good. This is going to be really repetitive for all these micrometers. Same process.
Hey Justin, are any of those printers set up on ABS?
No, not on is the basic
Is that like pretty temperature resistant?
100% temperature resistant. It's 1,000 times better than ABS.
Since I'll need to get with you. I printed a part that goes around my nozzle to get a better cooling airflow, but I could only print it in PLA.
Oh, yeah.
And it's starting to warp, and I
Right.
don't want it to melt or catch on fire.
This will hold +/-2, and it's super stable. So, yeah, I just did a super rough print of those holders for those parts that we're gonna do at 135.
What's the fastest MMS speed that they'll print at?
I don't know. That's a good question. I don't know that off the top of my head.
Everybody's 1 to 2 looking pretty good.
Eventually, I want to figure out like the fastest I can get my printer to go to like save time and stuff.
You have any 2-inch gauge blocks out there?
There are some 2-inch
Okay.
gauge blocks out there. You may have to get a little creative on some of your gauge blocks. So you may need to stack with somebody else's, or if you've got somebody close to you that you both have 1-inchers, you could You can do 2 inchers, you can use a 1 inch gauge block for the 0 to 1, or for the 1 to 2. There's 2 inch gauge blocks, there's 3 inch gauge blocks, there's 1 inch gauge blocks, and there's a whole
Gotcha.
litany of gauge blocks out
So
there.
if y'all have a 2-inch gauge block, go ahead and check it with the 2-inch, or get with somebody, stack a couple, and check the other end of it.
So when you're if you're gonna stack a couple of them together, and I saw some of you guys already doing it, so let's just say I have 1 inch ones, yeah. So, here I've got 1 inch, and I've got a 3/4. I'm gonna take them, clean the faces off with my towel, and then I can should be able to ring them together by just pushing them together, rubbing all the air out from them, and then they should be able to hold out just by pure pressure on there, so, not magnetism, but just vacuum should hold that on there. So now you've got 1 inch and 3/4, so you should be able to go to 1 inch and 3/4 on your micrometer and get that dimension. So, you guys have 1 inch? Okay, and then you probably had maybe 3/4.
We only had a 1 inch, oh, it was this one.
Yeah.
No, we only had one.
Everything looking good? Good. Okay, if those all check out, we'll go ahead and move over to the metric mic. Same thing, unlock it, rotate it out. You all know the process by now, I think. Once you've got it checked out, again, return it back to 0 by rotating clockwise. Use the friction spindle or ratchet to close the final distance to 0. The numerical 0 grad line on the graduated shell should be in alignment with 0, or I don't even know what that word is. I've never seen it before.
Where is it at?
Fluidical?
Fiducial.
Fiducial. Fiducial line on the sleeve within half the graduated line width.
Fiduciary line is that line that runs all the way across horizontal in the middle.
All good. Y'all should really know how to check a mic after this.
Absolutely.
This is way too easy, repetitive, and
It's a lot of repetition,
Right.
absolutely.
So if the micrometer has a vernier scale on the sleeve, the 2 0 graduations on the vernier must also line up with the appropriate graduation on the shell within half the graduated line width. Do they all line up? Okay. Everybody's checks good, don't need that. Do you want to check these metric with the gauge block? Do we have them?
We don't, we have a 25 millimeter gauge block, but we could do some conversions to the rest of them, so that we can go through and check them.
So go ahead and with whatever you got under 1 inch, check it out.
If you need to do a conversion, And if you have a normal calculator, that's fine. If you wanna go grab your toolboxes and grab your Machine Calc Pro out of there, I can show you a really simple way to do a pretty accurate way to convert standard to metric. I mean, you can do 25.4 or 03937 as well, but, so you'll take the gauge blocks that you have and we'll just convert them to a metric number. So everybody should have a metric micrometer, but you do not have a metric gauge block, so you'll want to do some conversion.
Once you get your conversion, go ahead and put it on your whiteboard, make sure everybody's got what they need.
Yes, do that. So you guys got a 1 inch?
Yeah.
Okay.
Sounds absolutely terrible.
Is it dried out?
Yes. Yep. What size gauge block do you have? What size is it? It is a 1 inch? I think you got it on the wrong side, it's 1 inch. I can't see from here, but.
Can you be open the calculator
Yeah.
real fast?
Oh, my
Yes.
God, no, it's not good.
I just bought like an article from Walmart, I'm trying to figure out how to
Yeah.
change
So
the
you
balance.
got 1 inch gauge block?
How to move the size of the fraction.
1 inches. Just double check. Convert your.
The metric ones only have 2 decimal places though, right?
Correct. Converted to a half inch.
We'll never use it.
Yeah, I know.
And if you do, it'll be digital, and it'll just be
And then all of this
hit a
fraction.
button and done.
You want to change that?
Very rarely. You'll see some metric stuff, but it's not very often.
Do we have a blueprint making class?
Yeah.
No? You should.
Why? It does
Because
it
I
for
have
you.
to make a lot of blueprints for work.
Confusion, it makes it for you.
Yeah, it just makes it for you.
Is it 40?
Yeah, pretty much.
You just, yeah, it's doing the whole thing for you as you're making it.
As you create the drawing, you can just convert it in.
Can Inventor
Yeah,
do
see,
that?
yeah, I bet they probably
I
find
wanna
that
say
on
Well,
Cause didn't we used to use
You got
Inventor?
someone, do you know how to do it?
I know, I've never touched this thing.
Okay.
can Inventor do that?
Yeah, I thought so. We used to use Inventor with Kevin, didn't we?
Mhm.
I hated that class.
So, what do you mean it'll like do it for you? Like,
So you're gonna make your drawing, right?
Yeah.
It's gonna have all your dimensions. And I don't remember the exact way, but I think you just,
Yes, you just
Convert
go
it
down,
pretty much.
you just go to drawing
right,
and hit drawing, and it automatically shows up your title block and all your information, name of your
it
part.
gives you different views and,
Yeah, it's got that, but then you still have to like drag out all the dimensions of stuff and put it where you want though, right?
Yeah.
Yeah, but.
It
that's just a
essentially
matter
does
of
it for
Putting
you.
the dimensions where you want them to be. I mean, there's no standard format for where a dimension needs to go. I
I
mean,
mean, you can draw a 6-inch line and put it up in the corner of the page if you want. It's still,
Okay,
it's still there.
That's like, I didn't know if like there's certain orders and all that stuff.
Yeah, I mean, I think that what you wanna try to work from is greatest importance to least importance. So I would put in all my datums first. I would put in all my feature control frames first. That takes care of a ton of your tolerancing. And then that'll set up your, what's primary, secondary, tertiary.
Right.
So work most important to least important. I mean, it does holes for, all you do is click the hole button and it does the
Automatic
quarter
center
20
line,
tapped
center
hole,
line,
2
so
inches
all
deep,
those.
whatever, yeah, I mean, it does all that stuff for you.
Okay.
I think I've
Now
seen
I'm working
everybody.
on a blueprint
Y'all had
that's
one.
got like
Good.
over 200 dimensions.
Yeah, they get pretty complicated. You guys can plot them out bigger.
Yeah.
What's your biggest plotting size? D?
Right now I'm on B. He likes doing 17 by 11. But yeah, we might have to go to there soon.
Yeah, I'd say by the time you start to get something, the more complicated it gets, the C, D size
Right.
are gonna be the ones that you want to start working with. Otherwise, everything it gets too small of type, like font, or like line type, or it just gets way too crowded. So yeah.
Yeah, because I'm about done with this model that's got like over 20 parts on it.
Those should all be separate pages though.
Yeah.
So depth mic. Did we cover depth mic in this yesterday?
We talked a little bit about the depth mic, so you can still have them go ahead and do, calibration to the,
To the gauge block.
to the
Okay.
gauge block and the granite table.
So everybody's gonna need a depth mic.
Freeze what's on the screen. No, I'm jumping in here. I think I did it on my phone, but I want to verify.
Oh, your order.
No. Let's go to, I'll jump into NC3 and we'll see about 6. I had turned 6 on the other
Oh, okay.
day. I want to turn it back off
How's that?
until they're done.
Oh, okay. No jumping ahead.
Yeah.
46.
Dial gauges, so it's like the bore gauges and stuff.
Oh, okay. Snap gauges, 4 gauges. Okay.
So it's gonna move to a sign.
So once you've all got your depth mic, make sure it's clean, make sure everything rotates, check your lock, all that good stuff. Same thing as your other micrometers. And when you do that, go ahead and check it with the gauge block to the surface plate. Stand up your gauge block and check it down. So they automatically close after everybody completes them? Or do you have to go and close them?
No, they'll stay open.
Okay.
But I wanted to close
Just
this
the exam.
last one on this because I don't want them working so far ahead.
Right. I don't think we'll get through 6 when I get into it.
This must be Yeah, I saw you and Brett working on 5. It's hard to pay attention to what we're doing when you're scrambling to answer a question.
I'm going slow.
So,
I think everybody should have a gauge block they can check with. Go ahead and check on your granite plate. You can move it around. Your whiteboard's not gonna be near as accurate.
alright, so you're on. Different perspective from the back of the class.
Once you all check that, retract and close the rod and recheck to 0 to ensure the tool repeats. You'll just bring it all the way back into 0, set it down on the plate, come back down a little, it should go to 0.
Is it what? So it's been on. So let's go with here. So you need a gauge block of at least 1 inch, so you need to grab. You guys have 1 inch? Wait a second. So this rod measures 1 to 2 inches, so set it down like this. So now it's 0. So you had your 3/4, you went down beyond it. And so that was just cranking it down past it. So once you go past this, you start to lose, you're no longer in the zone of what you can measure, so, 1 inch. You wanna keep solid pressure on this part of it, so go ahead and do that. You guys have your report right now. And then if you got the 0 to 1 rod in your, depth mic, then you can just crank it all the way down, set it on top of the granite table, and it should read 0. But you do wanna watch that ratchet will cause it to kinda, ratchet, and just kinda start to jack up, and start to kinda kickstand on that thing.
So we already did this. 0 to 1. Do you want to change rods?
I think they're okay,
Okay.
if they've got, it's all gonna be,
Gotcha.
the same process.
Okay. Yeah, it's just going through all of them.
Yeah, once they know how to do one, they should be able to.
On to small hole gauges. So once everybody's got that, we're gonna move on to small hole gauges. I think you're probably done with your micrometers. If we want to go and put them up.
I am not sure if they are or not.
No. Okay.
Why don't you hang on to them? I just can't quite remember. When you grab your set of small hole gauges, please grab there is an individual telescoping gauge, grab it as well. I don't know if they'll have you do that or not, because unless they just have you check a hole, and I can't remember off the top of my head if we do that or not. So you need just exactly what Desiree has in her hand. What's that? That is meant specifically for this certification training. I mean, all of these are normal shop use tools, but they're meant to be stored and calibrated in this set. So, like, we bought all this as one unit.
I just wonder why there's so many things in one box.
Yeah. Yeah, Snap-on cuts all that foam out for us and puts all those pieces in there.
That's nice.
It's very nice. You can take anything and send it.
What kind of phone?
It's called Kaizen foam.
Is that what it's? I can order a sheet.
Yeah, like almost everybody, so you can buy it on Amazon, wherever, yeah. So if you send it to Snap-on, you send them your tool numbers, and you tell them what drawer you want, they will cut it all out for you, so that it fits perfectly to their tools and their drawers. Pretty simple. You are welcome to go and grab one.
Okay, looks like everybody's got their small hole gauges, so grab one out. We're gonna check them over. Do the contacts move freely when the cone actuator is adjusted from minimum to maximum? Do the contacts stay in position while added pressure is applied to the contacts? And are the contacts free of dings, burrs, and wear?
Small hole gauge set measures about 1/8 of an inch to about maybe 500 thousandths.
Right, I think, yeah. Yeah, it looks like an 1/8 inch to 500 thousandths. So once you've done that, validate the minimum range of the tool. Use the calibrated 1-inch micrometer to measure the contacts when the compressed state. I don't think they read that right.
Right. Maybe
Yeah, they didn't.
in the
compressed state, not when. Validate the maximum range of the tool. Use the calibrated micrometer to measure the extended state. So measure with the gauge closed, and then measure with it open.
We can probably combine some stuff if you want to. We can go ahead and have them measure.
A couple.
Yeah.
Okay.
So with the small hole gauges, they can do some of these small holes.
Right.
And then they can also use the telescoping gauge to measure the through hole. They should have everything that they need to do that. That'll help kind of move us along through this part.
It's just stop once it's fully out.
It should stop, right? Yeah.
You talking about on the telescoping gauge or small hole
On the
gauge?
small hole.
Small hole gauge, man, you can probably crank it way down.
Right.
You gotta watch out because you bottom out those threads too. So, yeah, you want it to expand, but it shouldn't look like a V.
Right.
I saw some of you guys submitted scholarships, that's awesome, so I know I've got a couple to, check through, appreciate that.
So once you've checked one, we're gonna take our C or our 300 to 400 and check the second largest hole here, and then check it with your micrometer. Tell me what you get.
The second small.
Second largest. Don't overly tighten it in the hole and try and pull it out. You will scratch the crap out of it.
What do you think that reads?
Okay. Let me finish here. I think y'all are both good.
So it's.
Yeah.
You get it.
This might have,
Do what?
this one might not be gonna be.
What's wrong with it?
Unless you
Release it.
get
You got the
loose.
spring down as it goes. So you take it like this. Rock it back. Same process. So when you are done with it though, don't do that. You're done with it, take your fingers, release it.
Well, we wouldn't.
Oh,
They will, they eventually will pop out, they're just on a little bitty teeny tiny feet, super fragile.
Hey Justin, I think we got one messed up here.
I
Nope,
have,
never mind.
okay, I had to do a little bit of work on a couple
Yeah,
of them
it
that,
wasn't in all the way. It's
Yeah.
really fine thread.
yeah, they're really, really small, when we ran the summer group
Yeah, that
individual,
one is really tiny.
yeah.
Everybody getting answers on that hole?
Oh, you want it.
Yeah, if you would.
Which hole did you do, the next largest hole?
Yes. I think you're measuring the wrong hole. Go for this one here.
Yeah.
Not the biggest, put the next one down.
This hole,
Yes.
that's gonna be.
Mine's gonna hold this
So
way.
let's take one of these.
Yeah, yours is off too.
You could, just read.
It would be better.
Just so you feel better, I think that is the right size for the biggest hole though. So you were right,
That thing will move
just wrong hole.
This one may be on me. Might be up to here.
Is it stuck?
Yeah.
It spins,
Oh,
it's
is
just
it-
out of alignment.
I gotta go, let me go grab my pliers and flip it back.
So once everybody's got that, go ahead and take your snap gauge and measure the through hole. So the one that goes all, the biggest one that goes all the way through. Go ahead and write it on your whiteboard.
Low. That's why they call snap.
Mm-hmm.
That's kind of cool.
So the small hole gauges, they can not only measure small holes, but they can measure, you could do slot width on it too. So it's not limited to just that one thing.
When you go to check your measurement of the snap gauge on your micrometer, don't crank it. You will change this if you don't get it very tight. Loosen the, get it down in the hole, kind of get it at an angle, and then loosen your knob, and then rock it back straight, tighten it down, and come straight up. Did you get the drill hole?
Then just measure.
This one here, the big one. Okay. Try one more time. You're a little flip through some of these too. You wanna do the knowledge check, or are we gonna just,
I would just skip on, I think you've been pretty much covering it as you go.
okay. Good.
Oh.
Anybody have any questions or problems that they need to stop and do some answering of?
That's what
Yeah. No problem. There's a little variation, but it's pretty good. It's just a transfer tool, so you'll have a little bit.
It's under your chair.
Everybody think they got a good understanding of how all those work? Pretty good. Easy enough.
Clint doing a great job. Brand new instructor, leading you guys like a boss. Yay, Clint.
Do you wanna hit this part?
I kind of feel like we've been talking about this.
I mean, it's just repetitive. Just how to use them, how to read it. Y'all think you got a good grasp of everything we've covered?
Some of that, so all that we're trying to get here is basic understanding of tools and the usage of them. The real fine usage of them will happen as we're out in the shop
Right.
this semester. So this is just kind of 1,000-foot view.
Pretty good there then. Yeah. Let's see what that brings us to. Ignore Justin beating on stuff. Yeah, it's just everything we've already gone over. Looks like all the way through here. I think we're good. Y'all know how to take care of them, oil them down, all that good stuff. I think that is it for 5.
Cool.
Okay.
Move into 6.
Yeah, works for me. See if we can figure out what it is anyway.
It must be indicators, mag bases.
Oh, fun.
Yeah. Let's see what's called service. And PMI and
You haven't edited that one? You didn't edit that one?
I have not edited this one now.
Gauge and bore measurement.
So we'll go through. We know how to be safe.
Safety third, right, guys?
On the English micrometer, the ones up here are tenths. aren't they?
Correct.
10,000ths of an inch, yes. Okay. All right. So Clint's gonna take you through 6. Go ahead and leave what you have on the table, because some of those things we'll need to do some measuring with.
Oh, yeah.
Yeah, you're gonna need a mag
Going
base.
super simple.
I think the things that you're gonna need for this one are one of each of the things in the bottom drawer, as well as the indicators from the drawer up above it. So one of these, and then one of these, and then one of these. And it's gonna get your table a little bit full, but should take care of everything for you.
On some of the bigger ones, you can really.
Yeah, he's a senior.
Yeah.
He's a senior. Eli? I think they were crushing on him, they were trying to figure out who it was. Oh, yeah? Yeah, I think, it won't be so bad when there's not as many people in here, and once class gets started, we really won't spend that much time in here. But I am going to call Justin. I could do some checking.
Well, I mean,
The bore gauges are, I'm not in love with the bore gauges, and I'm not in love with the mag gauges. They, you'll see why now.
yeah, let's see what I have. Yes, those magnets are enough. So you
It's
can
just like,
grab out.
well,
Snake.
it's for the control part, but
Did everybody get an indicator with their base? Yes, no? So I've got one extra indicator right here, and they should all be out. Nice.
Oh god, that's tight. It moves super. Can you tighten it? Maybe I'll just announce it. Yeah, but like, you can move it if you like barely try it.
Everybody got a screw set too, so we're kind of covered up. Make sure everybody's got one of these in the bottom drawer. That's why he doesn't like them.
That is terrible.
See, I told you, you can tighten them up and they won't hold still. Yeah, so these are gonna be really crappy.
don't know what's wrong with your vision, mine's fine.
Like really tight.
Apparently she can tighten things tighter than you.
Mine is like,
Yeah, they're kind of crap.
look outside mine. It's all the way.
Okay, so we're gonna start with our dial indicator design. Over on the left side, we've got our movable dial, which you can see it moves. You've got your secondary dial, which is on the back side. The needle, your mounting stem, your contact point, which you can change. It threads in and out real easy. The bezel with dial cover, the bezel lock, your resolution, which is what you're measuring, what dimensions, your revolution counter, and your plunger. So your dial indicators will always have a continuous reading. They start at 0 and travel around the dial face in a numerical sequence used for linear distance measurements. So that just means the farther you push it, the more times it's going to go around until it bottoms out. So dial indicators have a balanced reading, graduated in both directions in equal increments, used to inspect or compare a known value to an inspection value. Once the gauge is zeroed to a standard, any reading to the left is smaller and to the right is larger. So say you're trying to indicate something in, you're going to come down and take it, say, one whole revolution back to 0, and then you can take that away from it, and without moving your indicator, put something else on it and move it to that same height so you know you're equal.
With the weight of the indicator now, it's terribly even worse.
These mag bases suck.
Can you tighten them at all?
Tighten which part of them?
This.
Mhm.
Cause like,
So if your mag base,
Oh, I think I see it.
if it's got problems,
Some issues.
Operator
Operator
it feels like there's a note there. But, so this section, I'm gonna pull this off of here for a second.
I've never seen a stare at mag base before, so I'm
Yeah.
not too surprised.
So there's pros and cons, and it depends on how you need to use yours.
Right.
If this is the mag base for you or not.
I remember from my old college one, it was just a bunch of rods that you had to keep adjusting to put the
Like this.
That's
Yeah.
doesn't get better
That's
than that.
pretty much everybody's standard. Those no-go ones that we have in our toolkits, they're pretty good as well. If you put yours on here, something like this, that'll be better for it. You can spin it around. And so for tightening or loosening, there is a knurled nut right here. That controls how tight it gets. So if I tighten that down and then go like this, I just keep adjusting it. Loosen this part of it, get it to kind of how much tension I want in it, and then, and so now it stays. So this knurled nut, and then you just put this jam nut back up against it, and then it'll stay. You're gonna have to keep, since you're partnered up, it's gonna be easier to do. You're going, when you have this thing out, it has a tendency to get pretty top heavy. So you're gonna need to have your partner kind of help you keep everything lined up. So you might see your mag base do something like this. Tighten it up, hold that back there, and then you can slip a gauge block in and out. So, but let somebody, because otherwise it's gonna keep tipping forward, and it's gonna end up smashing the thing. So it's got a lot of adjustment on it, but the fact that, like, you're limited to what those links will kind of bend down and move. So you don't get as much movement as you probably like to get.
So everybody's getting their indicator put on their mag base right now. Go ahead and get that done, and then we'll move on. Good, and you can mount it either way. You can mount around, or you can go through the backside. There's a hole. That's probably your better way to mount it. Either way will work just fine.
So on a dial indicator like that, you'll find that there's a bunch of different styles of backs that go on them. These are just flat backs that go on, so they don't have that lug on the back. There's magnetic ones. There's one that has a rod or a pin coming off of it. So those
Some
things
of them
are
are dovetail mount too.
yeah, absolutely.
Those,
Yeah.
I like dovetail ones.
Tons of different ways to mount things on there.
So on your indicator on the dial, you have a 1000th resolution, a 10,000th numbered, 5,000 staggered graduation, and your revolution counter of 100, 200, 300, 400, so on.
So you have small revolution
Right.
counter on there. It's counting each 100,000th as it
Right.
goes around.
So every time you make a full rotation, it'll move another number around that small dial in the back. So some of the features of your indicator are sharp bezel serrations for positive grip, a non-reflective white eggshell finish on dial. Millimeter models have yellow dials. That's probably just a standard thing. You will see metric ones that do still have white backs. Unbreakable crystal, hardened stainless steel stem, positive acting clamp locks in the bezel position, and a no glare satin finish on the case, along with a 375 mounting diameter on all AGD models. So that's kind of trying to sell their stuff again.
Does anybody remember what AGD is? American Gauge Design. So it's a gauging standard.
Some more features include 4 screw holes for 90-degree rotation of the back. Direct acting compression spring eliminates slide friction. Hardened stainless steel rack and spindle. A massive bridge for rigid bearing support. Replaceable low friction jewel bearings. Hardened stainless steel gears and pinions. Dial faces are color coded to avoid errors. So here is the difference between your standard and your metric. Again, that's the Starrett ones. You'll see different ones out there all the time. This is just some different sizes and variations. You've got your first one on the left, which is your ANSI Group 0, 1.25" or 32 millimeter. Your AGD Group 1, 1.11", which is just the size of the face we're talking about there. So it's bigger or smaller. And your AGD Group 2, which is a 2.25" face, so a little bit bigger. They all do the same thing. Your 3 and 4, it's just getting bigger yet. And there's some electric ones, standard, metric. So this is a different style. These are your contact points, which you can interchange. Starrett's got a cool little thing. They thread in and out so you don't lose them. Your roller contact, I don't think we have that one, do we?
What's that?
The roller contact?
Roller contacts we do not have.
We don't have that one. I've actually never even used one of those, but they're kind of
Not the
cool.
roller contacts. No.
Right. And then that there on your right is a different dial indicator. That's a dial test indicator.
Oh, no, not the roll. Okay,
So
Yeah,
here,
you
here's
have
just,
you have an indicator, yeah.
right. Here's a couple more variations. The one's on a comparator stand, and then that one shows you a heavy-duty upright mag base. Again, here's Starrett's mag base. Your indicator's snug, and that's just showing it mounted on the flexible post. Here you see a dial indicator diameter gauge. So that has a fixed point, and then your dial indicator goes on the end. You set it inside, it tells you your diameter, the difference there. And then your dial indicator groove gauge, that thing, you'll pull it back, set it in your groove, let it go, it'll tell you your reading. So here it's showing you some of the internal parts here. You've got your direct acting compression spring, which is what compresses as you press the rod up into it. Your pinion, your gears, hardened stainless steel rack and spindle and stem, and your bridge plate assembly, which is the whole thing there. Okay, here we're going to move on to the dial bore gauge design. You've got your housing, the main body, and the contact head. Again, uses the same interchangeable heads or anvils to allow for measurements between 700 thousandths and an inch and a half. Some features of the dial bore gauge have an ergonomic design with non-slip insulating grip. Again, that's just a Starrett thing. You'll see it with or without. Carbide contacts for extended wear. All anvils laser marked for easy selection. Gauge chart for quick and easy anvil selection. And includes a sturdy aluminum case with cutouts for gauge and all accessories. Your resolution is down to 5/10 or 5/10 thousandths. Some sizes and variations. Bore gauges are selected by measurement range, depth, accuracy requirements, and the number of contacts, which is 2 or 3. Some are available with interchangeable measuring heads for different diameters or extension of depth. They also have electric displays. Some come with output, micrometer type, vernier scales, or a dial similar to an indicator. So this here is showing you some different ones. Here we've got the one that you all have, the 2-point contact head. Again, it goes from 700 thousandths to an inch and a half. There is another 2-point contact head that goes a little bigger, from 3 to 5 3/16. And then again, bigger yet, that goes from 8" to 12 1/8.
You can see that when you get, go back. When you start to get bigger, you need more support, so you end up with these pieces out here just to help keep some balance in there. Right. When you're doing 4, 5, 6" bores, this is not enough. It's too hard to stay centrally located in there. So this just helps give us some balance. But still, essentially all it is a stick with an indicator. So it's just transferring that down. So all of them are basically the same inside. Right.
So here we got some more dial bore gauges. The one on the left is a split ball, so it's essentially the same as your little small hole gauge, just with a dial on it, so you don't have to transfer it over and read it. The top one there, you have a 3-point contact with micrometer head, so it's essentially a micrometer, but instead of measuring width, you're measuring diameter. And then same thing on the bottom, just with a digital readout electric display. Those probably go standard or, well, no, they're only standard or metric. They don't interchange, do they?
I don't know.
I haven't seen one that interchanges.
Ones?
Yeah.
I'm not sure.
They may not.
I would love to have one. It doesn't say. Oftentimes, if it's going to be one that reads in both, it would say
right,
like a metric equivalent on it. It does have mode. I'm not sure. It says inch here, so it's possible.
It could go either way.
I don't know. typically your electronics though will swap between standard and metric.
Here's another one. This is a electronic pistol grip bore gauge. I think y'all can figure that one out pretty easily. You squeeze it, it retracts, you let it go, it expands, gives you your reading on an electric screen. Here's some of the basic technology of how they work. Let's see. So up at the top, you've got your 90-degree transfer, which is on the back. That's the little lug that it goes through. Right? Am I seeing that right?
So I think it goes down through the center. It's what transfers
Okay,
that
yep.
down. And then it hits that centralizer, and then the centralizer, it holds it up against the back of it and moves that plunger out.
Right. So then you've got your measure plunger and your centralizer plungers, like you said. For your bigger ones, that just holds you steady, kind of keeps you where you need to be. Rust prevention, you all know that, same thing. Knowledge check, we kind of covered that. Okay, let's do calibration. So,
Field check of mag base should be pretty simple since
Yeah,
there
it's
is no
pretty easy.
measurable item on it. You know, you're just looking really for functionality. Does it do what it's supposed
Right.
to do?
So we'll go ahead and go over it real quick, just so we've done it. Number one, does the magnetic base on-off button move to a positive position without releasing? So that just means it should come over here and lock without like trying to come back to you. Number two, does the mag base hold firmly to a steel or cast iron surface when it's in the on position? The thicker the steel or cast iron, the stronger magnetic hold. You're not really gonna be able to do that. You might stick to your table leg or something, but
I'd stick to the side of that simulator.
yeah, that too, I guess. You want to try and stick it to the side of your simulator up there.
That magnet
It's not gonna
works.
screw with the electronics.
It will not screw
No.
with the electronics.
It's not that strong.
Yeah, and everything in the simulator is all solid state, so it's
Right,
not gonna
they're
have a problem.
protected.
It's not like there's a spinning hard drive or anything in there.
Looks like everybody's is working. Maybe. Very good. Okay. Can the magnetic base be easily removed from steel or cast iron when in the off position? So when you turn it off, does it move? Pretty much. Really
That's a
simple.
function.
Right. Does it do what it's supposed to do? On off. Number four, are the ground contact surfaces on the magnetic base free of dings and debris? So that is your mag surfaces on the bottom and the back, I believe, is this one? Yeah. Is the flexible indicator post secured to the mag base? So this actually threads on and off, I believe, don't they? There's
What's
a
that,
solid.
that part? The whole piece?
Yeah,
I
know a lot
think
of
the
the other
whole
ones
piece will
thread
screw
off.
on. Yeah, I don't know that you
So
need to. What's
it's
that?
secured.
Oh, it's okay, we'll get it. We get it.
With the flexible post lock disc gauge, does the flexible post rotate 180 degrees in any direction? So all they're asking is, does it do this pretty much anywhere?
Does it do this?
Does it have full range of motion?
Yeah, full range of motion. Yeah, that's good.
With the flexible post locking gauge, does the flexible post remain firmly in position? Justin kind of showed you all that a minute ago. With it in the unlocked position, you can turn the knurled nut, tighten it up some, lock it down. It should stay still. Does the indicator post snug, tighten, and hold the desired cylindrical object firmly? So that's just asking if you've got your indicator on the post side, can you tighten the nut down and get it to hold? Should be no issues. And can the cylindrical object be easily removed when the indicator post snug is loosened? So will your indicator go in and out freely when it's loose? So now we're going to go to the indicator itself and check it over. Release the bezel lock. Rotate the bezel. Does the dial move with the bezel? does the bezel rotate smoothly? Okay. Wipe the measuring surface of the contact and the exposed spindle diameter clean with a lint-free cloth. Is the spindle and contact free of nicks, dings, or worn areas? Should all be good there. Activate the spindle for full range of the dial indicator. Does the dial indicator have the range that it is made for? Does the tension remain the same throughout the full range? Does the spindle move smoothly without any stickiness? Does the hand move smoothly without any stickiness? So does it function well? Go ahead and kind of slowly just push it in all the way. Make sure it goes your full rotation. Should honestly go just a little past 0 when you go all the way around on the back gauge, the small one that shows you how many rotations you've gone. It should go just a little past 10 full rotations. Validate the dial indicator measuring accuracy method. Use a 1-inch gauge block to measure the linearity of the tool. So what y'all can do for this, since they do magnetize to the simulator, move your plate over to the simulator, lock your mag base down, and set it up over a 1-inch gauge block, bring it down, check it out.
We need to get some plates that they can.
Like 1/2-inch plates, probably like 6-inch.
Yeah, just something that they can set this
Okay.
down. So, like to transfer this to what you would do in your own toolkit, this is just the Noga mag base from your toolkit. I leave my indicator on there. So first thing you want to do is when you get that, when you open that up, loosen that thing up. Does that arm move? Does it spin? Does it do what it's supposed to? Ours will everything locks down by just tightening this up. This has a fine adjustment on it. This is the off and on. So it's similar but different, same but different on there. So just always want to make sure that your tools are functioning properly.
Probably want to mount a little higher up, like above that recess there, and you can just bend your arm down. Oh, you got plenty of motion there. Again, Justin was saying that one has a fine adjust. These mag bases also have a fine adjust. It's probably not as fine, but down here at the bottom, you can kind of do a little with it.
And if yours has that paper on it, you can pull that paper off.
Yeah, that's.
It's just a cosmoline paper. Okay, so you want this off?
Yeah.
Okay.
It's just a glove.
There we go. So here's what happened, is I imagine that you guys tightened it up and then tightened it. And then when you do that, it tightens it, so if you just turn it back the other way, it'll loosen back down. So there it's loose. Absolutely, yeah, they end up being worse.
Like most of your about done there. Don't be afraid to move things around where you need them to be.
Absolutely,
Everything
yeah, that
can-
table is your workspace, move it
I
wherever
probably
you want.
wouldn't try and pick that up. Just move your laptop out of the way and slide it over. They're not the lightest thing.
up
ones
in
in
some
there
of the 135s.
Okay.
And it doesn't
On the
line
granite
up
table
all
is a
until
good way to do
zero
it.
at the very end. Is
That's a full.
that's a
That's
full
what we're
thousand?
doing.
Yeah.
That we're
Okay.
basically
So, like, you
doing.
can
So
check
then I
it.
would just add 1,000 to it.
Well, not necessarily. So,
Like,
let's see here. 0 and 0 should be the same. So, like, I'm gonna turn it
These
to say
styles
200,000
come with
exactly.
a hole in them, so that you can run a rod through it, just.
So if I line up,
stuff like that on it.
Well, like,
so I'm at 205,
mhm.
and then I look there, my zeros line up
We'll just make some,
as they should. It's 205 exactly the same, just a little past. You take your closest lined up line is what it is. So if your zero is lined up, it's 0, 10. Simple.
So if I'm at 10 on there,
Okay. Oh, back here on the backside,
yeah.
on the small graduation,
Well, so 10
on the thimble.
yeah.
So say you're at 10, so that's 210, and then you check on around, and whichever line lines up the closest, that's how many tenths.
So if I'm at 10 and it lines up at the 0 though, then it would be 11.
It's still 10. This line, say you're 10 here,
Uh-huh.
but if you're on this 0, that just means it's perfectly 210. And then 210, 100, 1,000, and so on back up. But it's good. This one has a 0 on both ends. I don't know why. Most of them don't. They only go up to 9.
Okay.
That's probably what's throwing you off.
whoa.
Has everybody kind of got a gauge block set up? Kind of figuring out how? Pretty self-explanatory. Yep, pretty much. Okay. Looks like the dial bore gauge field check. Take inventory of the dial bore gauge kit. Make sure that the kit contains the proper number of extensions and spacers. Release the bezel lock. I think we really just did this already. Pretty much the same thing. So this one comes with a kit. That's what they're saying. Check, make sure you have all these. A lot of times you're not gonna have all these. You might have a bag of them or a box, something like that. So, let's see. Literally the same thing. You've already checked this range. You've already checked the tension, stuff like that. Oh, just kidding. We're on to a different gauge now. That's fine. We're onto this now. My bad. So you're gonna check it for full range of motion. The front side here is what moves. We good there?
Yeah, we just wanted to make sure that they knew quite what it was doing.
Gotcha.
I need force.
Do it.
I need force.
I don't. We can measure the one hole here probably. The biggest
You
hole.
gotta measure that big.
Yeah, it falls in between. But we'll have to. Justin, do we have the extension kit for these?
To make them bigger than,
Right.
you've got they should have grabbed the pieces here,
Right.
so they can go out to that 800.
Oh, the back side comes off this, not?
Yeah, so this
I've
piece,
never much of one, so.
this piece comes out.
That may be difficult on all those.
And they're in, I think there's some bags in there that have little wrenches.
Oh, okay.
So you just take, loosen that. And do a little how to do the gloves on.
Right.
And then you put in whatever, so this is the 700, that's 760, and then add shims to it, behind it.
Okay.
So I can go to there, grab this one. 780, I think that bore's 800.
Yeah, I was at 13.
Yeah. And I'll take like a shim.
Oh, okay.
So my thick shim. Set it back behind it.
You put pause on the
So there's definitely some things I don't like about that. I don't like that plastic body around it.
No.
So now I'm just going to go out to, let's just say, I think 812 is what it's supposed to be.
Yeah, they break it 813. I measured earlier, so it's 12
I'm
spot.
just gonna go, so let's go 813. And so now I just take it, set it in here, like this, and I'm gonna rotate my dial until I get to 0. So I'm at 22.
How do you change them out?
Okay.
And
So
so
take 22. So then
loosen this up. Yeah, bring it over here.
Yeah, it's about 25 and.
Is there like a little wrench or something?
yeah, he said there's a bag in there. I'll go look for it.
And so it's like, yeah, there should be some little wrenches in there. I've got these if you want to use that, and I'll walk you through.
Yeah, I'll do
Um,
that.
Okay, so you've got your dial bore gauge like this. If there's some little bags that might have some wrenches in the bottom, it's gonna be a really small, pretty flimsy little wrench. Where at? Which one? This one? Yeah, it looks like it's a little black wrench. And so what you're gonna do is this piece right here, it has a little hex on it, not like voodoo, but like hexagon. You're going to unscrew it, take it out, make sure you don't drop it. These things want to bounce around it everywhere. Justin, you might need to go grab one of those little black wrenches out of the bags in there or in that bottom drawer. So the bore that we're trying to measure is about 813. Okay, so that's what that through bore, actually both of those big bores on that PMI part, they're both about 813. So what you're gonna do, go ahead and let's get everybody to take their smallest little piece out.
We got a wrench.
Everybody have a wrench? Every group have a wrench?
Good. Yeah.
I'm just gonna disassemble mine, we'll just follow through the entire thing.
I've never had one to change in spaces.
Yeah, you guys probably set them on the gauge. Oh, you don't?
I used something like that over Garden Grove where they were all set for different boards.
Right.
You had a range and it was just different gauges.
Okay, so everybody's got this little guy in their hand. Screw it into.
Use the .86 one?
No, it'd be too big.
That'll be too big.
Screw it into the smallest one, smallest tapped hole size on this one. That's the 700. So if you do that right away, and I know the gloves suck, but that way you don't lose this thing. Okay, so screw it into the smallest one. Then you are going to take your second one out. You're going to unscrew the second one. Okay, so I took my one that came with the dial, took it out, stuck it in the first one.
Does the black piece need to
You will need a shim. Yeah, you will need the shim in just a second. So you put your second one in there. So now you want this one. You want to take that one out. You don't have a 780. I wonder if you already have. You have a 700.
Yeah.
I'm gonna take this. Yeah, this one is not only missing the 780, but it's missing one of the shims. I bet it's
There
on.
won't be any more back there. We've got them all out.
Oh, you got them all?
Yeah, there's 9 tables and we're the 10th.
Dang it.
The 780's not on the mic.
It's not.
Okay. So let's do this. I will take that one.
So we use the .78 one?
Yes.
You're gonna use a .78 one, and you're also gonna need one of the shims, so hang tight, don't get ahead of me.
What's the shim?
Hang tight, don't get ahead of me.
Just hold on.
Felt like I just said that.
I don't know, it might not have been clear.
So I'm gonna try and do this with what we got. I'm gonna get Justin
Gotcha.
our pieces. Alright, you should have a full set of everything. So you want this one out of that set. So take your second one out, that's your 780. And then you have this knob on the end. That knob has a 20,000 shim under it and a 40,000 shim under it. If you need to take your gloves off to get a hold of these, take them off. I can barely get, I got fat fingers, so I'm like trying to get in there and grab a hold of those things, and it's like, I feel like I'm playing Operation. And so, you wanna take the shim out, so you got 780, so go ahead and take out the 20,000 shim. There's two shims behind this, so unscrew this, there's two black rings. You're gonna take one of the smaller ring out, you're gonna put it behind the little piece with the hex on it, and then put it back into the bore gauge.
Use the 20,000.
Yep.
Yeah, so there's just a little washer, and so I've got a different one, I've got the wrong size one, so I'm gonna hold it like this, I would put that 20,000 shim on there, and then I will screw it back into here. You got two shims there, right? You got two shims?
Yeah.
Okay, you look super confused.
Okay.
So the idea you're getting as close to 800 as you can. So you've got a 780, then you've got a 20,000 shim, which makes 800 thousandths. Yeah, so it's the skinnier shim.
It's even better with your glove than what?
So then when you're reading it, you start with that
You don't know what it is yet because you haven't set it to a micrometer. Like, this is just an indicator springing in there. It's not set to a diameter yet. We're going to let everybody get there, and then we'll do that. I'm going to pull these off just so I can.
There's breath going.
Whatever. What's that? They probably got the indicator out too far. Yeah, so here's what I don't like about these things is they have Spirit's awesome. They have this plastic piece that goes around them, and this indicator is just a dial indicator stuck in a stick basically that has a rod in there, and it just extends it all. This thing moves up and down by loosening this. Okay. So what you're going to need to do, you're going to end up moving this thing up and down. You got to do some wiggling with it. To be honest, most of them don't have this plastic grippy thing around it, which makes it much simpler to adjust. This makes it harder to adjust because if you have to adjust it a bunch, you have to unscrew all these things and move everything up. It gets pretty complicated. So what I'm going to do next, you 780 and then the shim, right? Okay. So what I'm going to do next is I'm going to set my micrometer to 813. 0 to 1 micrometer, set it to 813. I'll let all of you guys do that. This works better if you've got a mic stand or you've got a bore gauge. There's several ways to do this that's easier than this. This is just one way.
What does this one do again?
That's so you can move your indicator up and down in that sleeve to get more travel on it. When you press it on it, does your dial move?
But then on this it moves.
Yeah, you're good.
Okay. This isn't perfect, but it's pretty close. I've got my micrometer set to 813. I've got my bore gauge set with the shim and the 780 on there. I'm gonna set my bore gauge in there. I'm gonna wiggle it around and see how I've got some rotation. I don't have, so that's where it stops, that's where it's loose. So I push it in there with some spring pressure. I see that when it zeroes out, it's at about the 20. I'm gonna loosen this dial up here. I'm gonna spin this around, the face of this around, to where 20's about down there, or 0's about down where that 20 was. So my idea is I want it to read 0 when I get it down there. See how that is?
It should be.
And honestly, that plastic around there makes it super difficult to do. I mean, when we finished this up this summer, I was like, I'm taking this off of all of them, and then I got lazy and didn't. But yeah, so 813. Why did I just say that? 813. You speak in Spanish today.
You said it should be 815.
Nothing wrong with Spanish. So I want, when I run this across here, I want it to read 0 with less than 1 full revolution of travel. Then that means when I stick it in this hole, I'm gonna scoop it into the hole, and if it's 813, it reads 0. If it reads 1, it's 814. If it reads -1, it's 812. See what I'm saying?
So is that little window of the middle, is that supposed to be like an average tolerance range?
These little movie finger things?
Yeah.
Yeah, that's the technical term, movie finger thing. Yeah, so if you were gonna set that bore gauge and that would be your tolerance, maybe plus or minus 5,000, you could set those little fingers so that an operator could come up and move this quickly and be like, yeah, it's good, or no, it's not. So the dial bore gauge takes a little bit extra to get set up. Super accurate though, so you can have these things down to a 10,000th of an inch, you can have it down to 50 millionths. So depending on what your bore size is, and so you can measure big bores with them, small bores with them, you get extensions for them. I mean, the ranges and the usages of them are really out of this world. They don't even have to just do bores. One of the things that I think we as students have a hard time understanding is that just because a bore gauge is called a bore gauge that you think it should only measure a bore, it can measure 2 walls too, it can measure a slot. You know, you can measure several different things. You can measure a height down to a granite table if you had a step. So like if you set it to the right thing, if I were to put this on the granite table, I can take my bore gauge and slip it through here, and I can measure step here to here. It's for any type of quick, repeatable, accurate measurements. So, like, as you enter that field and career, that's why I urge you guys to find jobs by the time you get to second semester. So, like, you can broaden that horizon, you know, because your shop will do things slightly different than the way we do them, and you're gonna gain a lot more as you do stuff.
What's when I hold it?
They take a little bit. They take a little bit to get used to.
You want to go ahead and.
Well, it's like holding the micrometer straight.
If you've got it, you made it all work, then you can disassemble the entire thing, and you can go ahead and just put the smallest one back in it, take the shim out, put the 780 back where it goes. Just make it like it was when you got it, if you would. So in doing that, we've checked our hole sizes just as we were doing this, so we've taken care of that part of it. So a lot of times you would have like a small precision gauge that already has that diameter that you're trying to get to, that's very helpful if you have something like that.
You're just like,
Are you able to rock it straight up and down?
You should be able to rock it, yeah, back and forth like this.
Yeah, a bunch of decent work.
4 gauges, yeah.
I just haven't really used them.
So the metric for the stair, the metric is the same thing. It's just yellow face one. And literally inside of these, all this is a just an indicator, just like the indicators that you have on here. And so sometimes they get jacked up, and you just replace the indicator off of it, put a new one in it, and back, good to go.
Why do they have
You
little
can
red
just
numbers?
lean down if we don't.
It's secondary.
Is that metric?
There's just a little bit on, you get the concept there.
Oh, yeah.
Oh, no, I know what it is. It's the dimension in the opposite way.
Oh,
So one way's positive, one way's negative.
all good?
I think that's it.
Probably so.
Let's see where we are.
We did this thing,
Yes. So,
went
just,
through all that.
I mean, the same thing, but metric.
Do we have the metric one in the kit?
We don't.
No, so we can't even do it.
There is some examples. We checked that board
Right.
gauge, so we did all of those things. So we just do it a little bit we're just combining some things together. as we
Honestly,
go.
they kind of over exaggerate.
Yeah, there's a lot. I mean, they're just trying to be really thorough. I'm taking somebody who maybe has never seen this before,
Right.
and I get it. Okay, I think that's it.
Okay.
Okay, if everybody is good and everybody has done this, does anybody have any questions? Okay, here's what I want you to do. Take a few moments, clean and quickly wipe down all of the tools that you have. If you need to get some oil, you can even put some oil on one of the paper towels that you have. Oil up real lightly, put away everything that you have. And so make sure you got a little dab of oil or some oil on there. There's some oil back in the box before you wipe everything down, so that to make sure that, because even if it doesn't look wet, it probably has some finger marks on it. And then that way you can put those things away. We're gonna put everything away. If you guys wanna finish out your tests today, you can do that. I deactivated 6, I'll reactivate 6 for the people who are in here. And then you can finish all of them up today. If you wanna print them out, you can use our printer. You can print them out yourself if you want to. If you're a little behind, like you didn't get all of yours caught up, like you're maybe back on 3 or 4, then you can get 3, 4, 5, and 6 caught up. So you're still currently in class time. So if you don't have all 6 of them done, and are confident in that, I would urge you to stay here as you do them. That way, if you have a question, kind of help you along as you go. Okay? So give me just a second, and I'm gonna go ahead and activate.
Where did your dude disappear to?
He's, I don't know.
Just took off.
He's in the bathroom. So I don't know. Not here.
Comment for this one.
So CLP would work for this type of stuff, right? If I needed to use it.
Yeah, I've got